In 2022, a spaceship with 2 aliens is searching in the universe. They are finding the solution to overcome the water scarcity problem on their planet. Suddenly, there is a glorious and beautiful blue planet grabs their attention. They scanned the planet with their smart magnifier and found that this was a planet named Earth, in which 70% of its surface is covered by water. They think that there must be a lot of their targeted treasure, fresh water. However, the analysis shows that only 3% of the water is freshwater, while the rest is saline water. For freshwater, 68% of them are locked up in the ice and glaciers. 30% of them is in the ground, and only 2% of freshwater can be easily obtained. They decide to enter the Earth to explore more about it. First, they reach African countries. They realized that the weather was hot and droughts, plants are withered, animals are dying of thirst, and people are worried about water. Obviously, these countries are facing water scarcity. They found out that more than 2.8 million children in Somalia and Ethiopia are already malnourished, putting them up to 11 times more at risk of dying from waterborne infections than well-nourished teenagers due to lack of clean water. After that, they continue their journey. At Al Jubair in Saudi Arabia, they found an industrial project, the largest desalination plant in the world, which produce up to 1 million meter cube of fresh water per day. The desalination plants are working to produce fresh water by extracting salt from the seawater. There are 2 methods for desalination, which are thermal desalination and reverse osmosis. For thermal desalination, the seawater is heated to its boiling point to form steam, then cooled and condensed to form fresh water, which is free of salt, minerals, and other contaminants. For reverse osmosis, the seawater is pressurized to flow through a water-permeable membrane. The salt particle will be filtered by the membrane, while the water molecules will pass through it. Fresh water is formed. However, they found that both of these methods have some environmental and economical drawbacks. These desalination plants need a huge operation cost. They release 76 million tons of CO2 gas per year, which is 0.2% of the global CO2 emission, and also dispose of huge amounts of hypersaline brine, which is harmful to the aquatic ecosystem. They felt disappointed and continued their journey. Suddenly, they found a city full of renewable energy and green technology. This is the Hidden Advanced Country, USM. They landed in the city and meet 3 scientists who are doing research. They are curious about how USM can get fresh water without jeopardizing and harm to the environment. The scientists told them to get fresh water in USM, there were 3 different ways. In the coastal city, they built a huge spherical structure, which is the main component of their first method, solar dome desalination. This solar dome is surrounded by a huge number of parabolic mirrors that focus and concentrate the radiation on it, thus heating the seawater from the ocean and facilitating evaporation to produce steam. The high pressurized steam is flowing through the turbine and produces electrical power that is used for the condensation of steam to form fresh water. The cost of water for the solar dome desalination is only 34 cents per meter cube, which is lower than the cost of common desalination in the market, 53 cents to $1.31 per meter cube. In the city, the method used by USM is atmospheric water generation. Every house in the city is installed with an atmospheric water generator, which is also known as an AWG system, to produce fresh water. The AWG system absorbed the air from the surroundings and filtered 99.97% of particulate matter all the way down to 0.3 micrometer, meaning dust and dirt will not enter the systems. The air particles are then cooled with a coil until their dew point, achieve 100% relative humidity, and condensed to form fresh water. For the home-based unit, the AWG system is able to produce up to 20 liters of fresh water per day, which is enough for the daily drinking consumption of a family. For the commercial scale unit, the system can produce 1,000 to over 10,000 liters of fresh water per day, which can help the companies to reduce their water costs. The most important thing is this technology is eco-friendly because all the power consumed is provided by solar energy. In foggy areas such as mountains and deserts, the water harvesting process is carried out where the fog nets are used to trap the water vapor in the area. The fog nets, which are made up of polyethylene fiber, are placed vertically at a foggy location for inducing the fog droplets to flow down towards a trough below. The electricity is connected to cool the net fiber and make it electrically charged, increasing the ability and efficiency to collect water. Depending on their effectiveness, fog collectors can collect from between 2% and 10% of the moisture in the air. A standard fog collector with a surface area of 1 meter square can collect from 5.3 liters to 13.4 liters of fresh water depending on the season. The aliens are surprised and happy to have this communication with those USM scientists. They are planning to apply the knowledge that learns from humans to help their planet to overcome the water scarcity problem.